Welcome to Study Loop.
Okay, so for this problem, we're given the radius of the Earth, which is 1.50 times 10 to the 8th kilometers, and we know that it takes 365 days for the Earth to rotate around the Sun. So the time t here, or the period, is going to be 365 days. Okay. So now we're being asked, what is the magnitude of the orbital velocity of the Earth in meters per second? So we want to find v, the velocity. And then part B is asking, what is the radial acceleration of the Earth toward the Sun? Okay, so we want the radial acceleration. Okay, and we'll work on parts C and D after that then. Okay, so we want the orbital velocity. So we know that velocity is just a distance, which we call x, over time. And we know the distance that the Earth is going to travel is going to be 2 pi times the radius, because it's just going to travel around in a circle. So we take the circumference of the circle, that's going to give us a distance. So x is going to be 2 pi r. Okay. And now we have to convert r and t to the proper units. So r to be in meters. So we can convert the kilometers to meters then. So in order to convert kilometers to meters, we just multiply this value by 1,000. You know, there's 1,000 meters in 1 kilometer. So our radius is going to be 1.50 times 10 to the 11th meters. Okay. And now the time, we want the time to be, or the period. So I'll use period and time interchangeably here. So the same thing. So we want the time to be in seconds then. So we'll convert days to seconds. Okay. So basically, if we convert these days into seconds here, using the conversion factor between second and days, we're going to get 3.16 times 10 to the negative 7 times 10 to the 7 seconds. Okay. And I'm just converting 365 days into the amount of seconds that takes. Okay. So we have that. Now they're in the proper units. So we can plug in the value for r here, plug in the value for t in the velocity equation, and then solve for the orbital velocity. So if I do that, I'm going to get 2.99 times 10 to the 4th meters per second. So that's going to be my orbital velocity. And now I'll compute the radial acceleration. We know the radial acceleration is going to be v squared over r. So I plug in the value for v here. I plug in the r value that I'm given. I'm going to make sure r is in meters though. So if I plug in those two values, I'm going to get 5.95 times 10 to the negative third meters per second squared. So give me the radial velocity. Okay. So now what about parts C and D? So for C and D here, it's saying repeat parts A and B, but we're using the planet Mercury now. So Mercury has an orbital radius of 5.79 times 10 to the 7 kilometers, and its orbital period is going to be 88 days. Okay. So basically we're changing the R value and the period here. So C, we're going to find the velocity So I'm going to find the velocity when R is equal to 5.79 times 10 to the 7 kilometers. And the period T, or the time, is going to be 88.0 days. Okay, so I'm going to find V with those conditions then. And then D is asking, what is the radial acceleration when R and the period are these values? Okay, so let's put middle marks here. Okay, so what we do to solve this is we just repeat the same exact process here, but we use the different R value for Mercury and a different period for Mercury. Okay, but the exact process is the exact same thing. We just have different values for R and for the period. Okay, so if we repeat the same process, I'm going to get an orbital velocity. Okay, so the orbital velocity, if I use the values for R and T, is going to be 4.78 times 10 to the fourth meters per second. And the radial velocity again is V squared over R. So I take the value for V here, I plug it in the radial velocity equation, and I use the R value that I've written up here. If I plug in those values, I'm going to get 3.95 times 10 to the negative second meters per second squared. Okay. So it's going to give me the orbital velocity and the radial acceleration for Mercury.